For this example, we're going to make use of the negative angle identities. Notice it says y is equal to 2 minus the sine of negative x. Remember the negative angle identity for sine. It says that sine of negative x is equal to negative sine of x. And if I sketch negative x here, this would be here. That's negative x, and this is positive x. They measure the same. This is the same angle. My coordinates here for cosine and sine on quadrant 1, cosine and sine are positive. But in this quadrant, cosine and sine, cosine is positive, but sine is negative. Okay? Here they're both positive. So that's why the sine of negative x is going to equal to the negative of the sine of x. That's where this identity comes from. So if I substitute sine of negative x for negative sine of x, this is what happens. Now I'll have y is equal to 2 minus, and then instead of writing sine of negative x, I'm going to write negative sine of x. And this becomes 2 minus negative is 2 plus sine of x. And this is very simple to sketch. Sine of x starts at 0. It starts at 0. It reached, let's say this is 1. And this is negative 1. So it starts off here, reaches its maximum, and then reaches its minimum, and it reaches 2 pi. 1, 2, 3, 4. Yep, 4 intervals. There's your sine function. And you can continue this. You get the idea. Now, plus 2, that is the same thing as having y is equal to sine of x plus 2, right? It's the same thing. So that means I have to translate this x-axis 2 units up. So 1, 2. I would have to bring the x-axis up to here and then sketch my sine function like that. Okay? And you can continue. And there you have it. Let's see this in GeoGebra. Here I have the 2 minus sine of negative x. Here it is. What happened was the x-axis came up 2 units, and there you have your sine function. Simple as that. So don't go crazy doing all the steps I showed you in other examples. Look at the function first, see if you can apply identities, and it's much simpler work. I'll do another example.